So today we're going to go over how to intuitively plot functions that result from a convolution. And we'll start with a step convoluted with a step. So we'll do this in the time domain. So here's the convolution equation where we substituted the dummy variable tau, right? And the second function, we just happen to substitute t minus tau. And we have to do that because the upper limit is actually the function of a function of t, right? So just a quick review, we set the limit from 0 to t, right? So that means those step functions are 1 in that domain, right? We integrate, we get tau, we evaluate that integral, and we get t. But we have to multiply that by ut because the integration limit is, the lower integration limit is 0, which means there's no area, or the function is 0 before time equals 0, right? And just a quick idea, right? If this is my x and axis time, right? This is t, right, in time. But this isn't what we're going to get if we do the convolution. We're going to get a ramp. And what forces this into this is multiplying it by the step function. You have to do that manually. Now, from a graphical perspective, right, here in purple, I've got the step function and it's reversed in time, right? Now, if I just had u minus tau, I would just get this, and that would be 0, right? And that would be tau. When I add the t, well, this I'm changing it, right? It can be -1, minus 0.9, 0, 1, 2, 3, infinity. But I'm stepping that, right? Um, in an animation, you're stepping it. It's continuous, but it's helpful to think of it as terms of stepping. But if I'm below t equals 0, and yeah, we're sharing an axis here, there's no overlap, right? So if there's no overlap, there's nothing to integrate, right? Because 1 times 0 is 0, okay? Over here, 1 times 0 is 0. So there's just nothing to multiply. So now when t is greater than 0, it is overlapping. And so this area here, right, is the actual function of this convolution. And as we step t linearly, in fact, this area increases linearly, and we get our ramp function. Now, we're trying to, draw an animation, which is kind of difficult. But in this case, right, you just intuitively draw before they overlap, which is going to be 0. Then you show it as it is overlapping and try to see what the resulting type of function we're going to get. Now, step times step can almost do it by inspection that this is going to be a linear function. All right. Now let's go look at a Python animation. And we can see that as time is moving forward, that orange line, the orange step is moving from left to right. And there's our overlap. And I'm integrating up to this point. Always integrating up, and that area is increasing linearly with time, and you can see that, right? Then it goes again, right? There's no overlap, so there's, nothing to integrate, nothing to integrate. And here we go. Now we're starting to integrate. And the longer time goes on, the more there will be to integrate. There's nothing bringing that area back down. Okay? And just to call it out, F1 of tau is U tau, F2 T minus tau, right? And then this is just them multiplied together, which we're shading with that. So it's probably a good idea just to watch this a few times, the animation part a few times, right? So you can really understand what's going on, that this is moving in time. So we're kind of integrating in time. Not kind of, we are. But, right, I integrate up to here and I get that point. I integrate up to here and I get that point. I integrate up to here and I got that point. So you can slow down the animation in YouTube. So that should be helpful to see these points. But really, in this particular example, it's not overlapping, and then it is. So there's really just one time point where something actually changes, right? Which is really what we get here. We have one point in time where the shape, the slope of the curve changes, or the level of the curve. All right.